All right, this is Mr. Gillum, and today we're going to start talking about proportional relationships and looking at those in equations. Um, and so I guess the first thing we can talk about is what the word proportional means. Proportional is a way to say that two fractions or ratios are equivalent. So a way we could write that would be like 2 to 1 would be the same thing as 4 to 2 would be the same thing as 8 to 4 be the same thing as 16 to 8, and so on. Okay, and we talked a little bit about this. It's very similar to equivalent fractions. We can write those ratios as fractions as well. Today, though, we're going to be looking more at, instead of ratios with the two dots in between the colon there, as fractions. So instead, we're going to be thinking like this. Something like, we'll say 3/4 is equal to 6/8. That would be a proportional relationship because 3/4 really is equal to 6/8. We know those are equivalent fractions. 7/9 is equivalent to 63/81. If I multiply them both by 9, I know that they will be equivalent. And that's kind of how we talked about some of the relationships that we did yesterday on our worksheet. Is we thought, okay, well, if the 7 changes to 63, then I know it multiplied by 9. If the 9 changes to 81, then I know I would multiply it by 9. Or if I didn't know what this was, I could multiply it by 9 to figure out what it was. And so we used our intellect, our intuition, our careful problem reading to figure out what the equivalent fractions would be. But today we're actually going to learn a little bit about algebra and how to solve what we call proportions. And a proportion is a comparison of two equal ratios. But a lot of times, so this would be considered a proportion, and it is modeling a proportional relationship. But it has to be in the form of fraction equals fraction. Okay, and this is so very important that you do not get this confused with multiplying fractions. Every student has a hard time. In my experience, students have a hard time determining what is a proportion and what is a multiplication problem for whatever reason. And there are strategies for proportions that are not used for multiplying, okay, operations with fractions. Okay, just as a preface, I just want to make sure it's very clear that the fraction must equal the fraction. And so again, proportion might be 3/2 equals 6/4. That is a proportion. It is modeling a proportional relationship. But today we're going to have what we call proportions with an unknown. So we might have x over 2 equals 6/4. Okay, and so this is called a proportion. We're going to learn some specific strategies to solve proportions. But again, yesterday what we were thinking was, oh, okay, well, it looks to me like the 2 changed into a 4. So if I multiply this by 2, what would it be to get to 6? Oh, it would be 3. And so we knew that 3 would be the answer. And so we were just kind of using our logic, or really what we were doing is the same type of thing with our building block skills, just our mental math skills. But today we're going to actually learn a strategy on how to solve proportions with algebra. Okay. And so with our current knowledge base, what we might know how to do is eliminate all the fractions in one step by finding the least common multiple. And so we practiced this in the equations chapter, and I noticed, oh, well, 2 and 8, if I don't like having fractions in my equation, if I multiply both sides by 8, I know that I can eliminate all the fractions at once, and I'll have 4x equals 6. And then I could solve by dividing by 4, and I know that x would equal 3/2. And that's one of the strategies that we've solved before, which is a great strategy because that's a viable way to solve that equation. In this case, now we know that it is a proportional equation. Okay, it's got a proportion relationship. And again, it works for a lot of these proportions. I can multiply both sides by 36. And if I think about it as 36/1, I know that 9 reduces with the 36. And 4 times 7 is 28. And I know 36 reduces, and so I have x, so x must equal 28. And so we've practiced this, and we know how to solve equations with fractions because we can always multiply both sides by the least common multiple. However, there are proportional relationships that we cannot do that. Or maybe we're not advanced enough in algebra. There is a way to multiply both sides to cross-cancel the x and cross-cancel the 16, but I think it's a little too advanced for us right now. And so what we did yesterday was we thought of it similarly to this, but we really thought of it as like 3 to x equals 12 to 16. We thought of it like this. I'm trying to change the 3 to a 12, and what we want, it's got to be a 16. So we know that if I multiply the 3, what times 4 would equal 16? Oh, well, x equals 4. And so we figured it out that way, which isn't very mathematically sound. It's logical, but it doesn't really follow any certain pattern of algebra. It's more of a mental math thinking strategy. We're going to learn a strategy today how to solve these even when the variable is in the denominator. So you can see that it would be difficult to use this multiplication strategy with letters in the denominator. And I would like you to know a little bit better strategy than trying to think of what number multiplies to get the top and what number would have to be down there in the bottom. Because, I mean, even if we were going, okay, 5 times 4 would equal 20 times 4, we could figure it out. X must equal 12, but things get a little more difficult as we start adding the distributive properties. So we're going to learn a strategy for solving proportional relationships today. And I want to make very, very clear that a proportion is a fraction equals fraction. Fraction equals fraction. Fraction equals fraction equals fraction equals. Whew. Okay, I hope that I made that clear what a proportion is. A fraction that equals another fraction. Okay, that's the relationship that we're looking for. And here is the word that I'm very, very scared to introduce. It is the word cross multiply. Okay, and we are going to use cross multiplication to solve proportional relationships or equations modeling proportional relationships. And so I can't emphasize this enough. It's only used for proportional equations or proportional relationships in equations. Okay. Now the first thing we're going to do is cross multiply, and the second thing we're going to do is we're going to solve the equation using inverse operations. All right, so let's take a look at some examples here. I want to be very, very clear. These are proportional because it is x over 2 equals 6 over 8. 7 over 9 equals x over 36. We are not taking x over 2, multiplying it by 6 over 8, okay? There's a whole separate, that is multiplying fractions. That is not solving proportions, okay? This is multiplying fractions. We know how to do this already. This is a whole different thing. These are proportions. A whole different set of rules, and there's only one sign difference, and that's why it's easy to get them confused. One has equal signs, those are proportions. One has multiplication sign, that is multiplying fractions. Please keep those two separate, okay, in your head. This is a whole new thing besides, this is not an operation on fractions. This is an equation that we are solving that is a specific relationship. We call it a proportion. So here we go. Step one, we are going to cross multiply. I really, really hope that this does not affect our ability to multiply fractions. This is not what we are doing. Right now we are solving an equation, okay? I know that the answer to this equation is 3/2 because we already solved this one earlier. Here's how I would solve this using cross multiplication. This works only for proportional relationships and equations. If I multiply 8 by x crossways, or x by 8, however you would like to think of it, I know 8 times x is 8x. Then I'm going to set my equal sign, and I know that when I multiply 2 times 6 or 6 times 2, however you'd like to think about it, that equals 12. And so what we actually get is 8x equals 12, which is the same exact thing that we got. It's almost the same exact thing that we got when we did it this way, 4x equals 6. It's the same exact equation except for the numbers are smaller on that one. On this one, the numbers are just a little bigger, 8x equals 12. And so now what I have is just a one-step equation that I can solve using inverse operations. The inverse of multiply is divide, so I'll divide both sides by 8 and reduce both sides. 3 over 2. There's my solution. So again, we can solve these using mental math. I know 8 divided by 4 would be 2. 6 divided by 4 would be 3/2. 6 divided by 4, 6 over 4 equals 3/2. So I could think of it that way and solve it. but that's not really algebraically sound. It's going to be very difficult when we use a distributive property here in a second. So today we're learning how to solve proportions. We're not multiplying fractions. We are learning how to solve proportions using cross multiplication. Okay, and we solved this one earlier today too. Unfortunately though, one of the, I wouldn't say detriments to multiplying or cross multiplying is that sometimes the numbers get kind of big. Unfortunately, there's no way to really help that. So when I multiply or cross multiply 7 and 36, I get 252 equals, and I'm going to multiply across 9 and x, 9x. Now I'm going to use my inverse operations. The inverse of multiply is divide. So I need to know what 252 divided by 9 is. So I know that x equals 28. So as you can see, we could solve this a lot of different ways. I know 9 times 4 equals 36, and 7 times 4 is 28. That might seem like the easiest way, but again, when we start using the distributive property, it's not going to be so simple. And you can see that we got the same solution different ways earlier already. Now here's one of the main benefits of cross multiplication, the problems with variables in the denominator. Let's take a look at what happens here. That problem that we have never learned about how to solve before. Using cross multiplication, I see that 3 times 16 is 48, and 12 times x is 12x. Inverse operation says I may divide both sides by both by 12 because the inverse of multiply is divide. 4 equals x, or x equals 4. And now, through cross multiplication, because I'm using a proportional relationship in my equation, I can solve the value, and I know that x equals 4. So again, we could think of it as divide by 12, or multiply 3 times 4 to get 12. Something times 4 equals 16. We would know it's 4. You can think of it that way to check your answer, but cross multiplication is going to be very beneficial here in a second. So let's practice one more time with cross multiplication. 5x equals 60. All right, and then I'm going to solve my one-step equation. X equals 12. And again, you could think of it as, well, I multiplied 5 by 4 to get to 20, so 3 times 4 would equal 12. And so this is connected to ratios, and it's all proportional relationship related. And so we're going to practice that worksheet again using proportions here in a couple days. Here's the tricky part, though. Now we have some proportions with more than one term, and so these are going to be a lot harder to use mental math on to check our answers. But we can use cross multiplication because we have fraction equals fraction, okay, and they're proportions. So I can use cross multiplication and then solve my answer. So when I use cross multiplication, this time we need to actually write it out 2 times, and because I'm multiplying more than one thing, I need to write it in parentheses. X plus 2 equals 4 times 5. All right, and I'm going to write it just like that, and I would like that step to be on your paper as well. Now the mental math aspect has kind of been removed. Okay, it's going to be really hard to figure this one out with mental math. We could solve this one still by multiplying both sides by a least common multiple, but that's going to get messy as well because sometimes it's easy to forget to distribute. So let's go ahead and use cross multiplication, but these parentheses are very important. So I wrote them in 2 different colors. They're so important. Here's a third color even. Okay, those parentheses matter because if I have the parentheses, that shows me that I need to distribute 2 times x and 2 times 2. And so as I simplify this equation, now I have a 2-step equation. Now I can use inverse operations again. So these parentheses really, really matter as far as making sure that we distribute everything. So now I'm going to subtract 4 from both sides of the equal sign, leaving me with 2x on one side. That adds to 0, 16, and divide by 2. The inverse of multiply is divide. You know that x must equal 8. All right. So I think I'm going to start the next one here, and I'm going to use cross multiplication because I have a proportional relationship. I'm going to multiply 3 by 10 is 30. I'm going to multiply 6 by x minus 1. I like to have my multiple quantity second so I can see quickly that I can distribute. 30 equals 6x minus 6. Inverse operation says I can add 6 to both sides and divide by 6 to find my solution. All right, we're going to do a couple in class, but that's it for today.